Pascal's triangle, there's a bunch of different patterns that end up showing up in this. We're not going to be able to get into all of them. I'm sure in the future they're going to find more patterns hidden inside this triangle. It's a pretty big triangle, like literally and just like as a concept. So we can go farther. We can add a row 6, we can add a row 7. We're not going to get too far into it, but I am going to write out the next row and see if you can kind of pick up on the pattern of what maybe the 7th row would be. So 1, 6, 15, 20, 15, 6, 1. And then that is our row 6. And I don't have it memorized. It is written in front of me, but I didn't look at it to figure it out. There's a pattern to figure out the next row. So what do you guys think the first number in the 7th row is going to be? 1. And then what about this next number? 7. And then what? Ooh, you're picking up on the pattern. So we're just adding we're adding the previous terms together. And then ones are always at the end. So if I look at 1 plus 6 is 7. 15 plus 20 is 35. 15 plus 6 is 21. 20 plus 15 is 35 as well, and kind of so on. So you just add the two values above it. So there is also a way to identify the numbers of the rows without looking at the previous ones, but we'll get into that in a minute. The reason why I want to talk about Pascal's triangle today is something happens if we're trying to expand a binomial. Remember, a binomial is 2 terms. So we're going to start with row 1 is representing x plus y. Row 2 is representing x plus y squared. Row 3 is x plus y cubed, x plus y to the 4th, and so on. And the reason why I'm saying it's representing this is because if we were to expand these out, we'd get x squared plus 2xy plus y squared. Okay, and you can expand that out on your own if you want. X plus y cubed is going to be x cubed plus 3x squared y plus 3xy squared plus y cubed. And then x to the 4th, I'm going to need a little bit more room, is x to the 4th plus 4x cubed y plus 6x squared y squared plus 4x y cubed plus y to the 4th. I got it in there. It's like off the screen on mine, but on there on yours. Now the reason why I'm saying it's representing those is because look at this. 1, 1. Those are my coefficients. 1, 2, 1. 1, 2, 1. Let me use a different color. 1, 3, 3, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. So that's how we're going to kind of use it today, is we're going to expand something. And I'll show you kind of the trick with it. And then I'll show you a couple different ways to use it. The exponents start at the highest term. So there was a 3 here, 3 here, 4 here, 4 here. And for that first piece, they decrease. So 2, 1, and then they're gone. 3, 2, 1, and then they're gone. 4, 3, 2, 1, and then they're gone. And then you can either think about it as it starts from that highest piece with the second piece. So 2, 1, and then it's gone, just going in the opposite way. Or the exponents have to add up to this 2 or to the 3. So if 3 of them are being used, y doesn't have anything left. 2 of them are being used, y gets 1 more. We need this is the 5th, so I need the 5th row of Pascal's triangle. What was the 5th row? 1, so row 5. We need 1, 5, 10, 10, 5, 1. And then the way that this is going to work is I'm going to write this a little different. So I'm going to put these coefficients vertically, 1, 5, 10, 10, 5, 1, because it ends up being a little easier to work with. So this is my first piece. So that would be like my x term, so 2k. And we start with the highest exponent, so to the 5th. And then we decrease each time. 4, 3, 2, 1, 0. Then we're going to take -3 as that second piece. And there's multiple ways to think about it. These exponents with these 2 pieces need to add up to 5. So 0 and 5 add to 5. 1 and 4 add to 5. 3 and 2 add to 5. Or you can think about it as starting at 0 and increasing by 1 each time. Or you can think about it as starting at the bottom with the highest and decreasing as you go up. These are going to be my different pieces of my expression expanded out. I just need to add them together. But writing it this way seems to be a little easier for some students to kind of work with. So I'm going to go through and simplify this. And I'm going to write out a lot of detail on this one. Just kind of go with it. 1, didn't do anything. In terms of exponents, this is going to be 2 to the 5th, k to the 5th. Because that's the property of exponents. If I have 2k quantity raised to the 5th, then the 2 and the k both get the 5. And then anything to the 0 power is 1. I'm going to do it again. 5 times 2 to the 4th, k to the 4th, and now I have a -3 to the 1st. So I can put the negative out front. You can leave it with the -3. It doesn't matter. I like to pay attention to my signs at this point. And then I have 10 times 2 to the 3rd, k to the 3rd. If I square a negative, it becomes positive. Then another 10, 2 squared, k squared. If I cube a negative, it's going to be negative, and then it's going to be whatever 3 cubed is. We'll figure it out in a minute. 5 times 2 to the 1st times k to the 1st times a positive 3 to the 4th. And then I have a 1 times anything to the 0 power is 1. And then this is going to be negative, whatever 3 to the 5th is. This one's positive. Then I can type in my numbers into the calculator. So in the calculator, I'm going to write 1 times 2 to the 5th times 1, and then include the k to the 5th. In the calculator, I'm going to do -5 times 2 to the 4th times 3. That's going to be my k to the 4th term. And then 10 times 2 cubed times 9. 10 times 2 squared times 3 cubed. 5 times 2 is 10 times 3 to the 4th, k. And then I'm going to have a -1 times 1 times 3 to the 5th. So that's kind of how we're going to set it up in the calculator. So I don't need to multiply by 1. So I'm just going to do 2 to the 5th. 32. So that's my first piece. So I have a 32 k to the 5th. So I'm going to write my final answer this way just because I'm out of room. But if you were to write your final answer this way and put a box around it, that's fine. Now to find this term. -5 times 2 to the 4th times 3 to the 1st. -240. So that's minus 240 k to the 4th. Then I'm going to do 10 times 2 cubed times 3 squared, which is also 9. We wrote it down as 9. 720. So now I have plus 720 k cubed. And now I have a -10. That is not 10. Times 2 squared times 3 cubed. So minus 1080 k squared. And then we have 5 times 2 times 3 to the 4th. So 5 times 2 times 3 to the 4th. So 810. And then it's minus 1 times 1 times 3 to the 5th. So we get 243. So then this is our answer. So to remind us of what it was that we were even trying to do, this is 2k minus 3 to the 5th. So yes, at this point, it probably would have been faster just to do 2k minus 3 and multiply it together 5 times. You're going to get faster at this, and it's going to actually be faster to do this kind of expansion. The downside is you have to know Pascal's triangle. So there's also a way you don't have to know Pascal's triangle. So we're going to go over a couple notation things. So what a factorial is just there's an exclamation point, and you are going to take the number, oh, it just like, I don't know what it did on my phone. You're going to take that number and then multiply any of the previous integers down to 1. So you're not going to multiply 0. But so the factorial of 3 is 3 times 2 times 1, which equals 6. 0 factorial is 1. There's a reason for that. We're not going to go into it, but if you are interested in that, there's a couple kind of thoughts on it, and I can walk you through some of the stuff. Combinations is if I have, so for our first example, this 7, 3 right here, this would be if I have 7 things, how many different ways can I pull 3 of those items? So if I have 7 people who I need to take 3 of them to the park. I don't know. I have 7 kids and only 3 of them get to go to the park. How many different ways can I pick just the 3 to go to the park? I don't know. So that's what a combination is. And to do it on a calculator, you have to hit the n value. So whatever your top value is, or if it's written off to the side like NCR, you type in that number. Then you can hit math, go over to the probabilities option, and then it's usually the third option. You hit enter on that. Then you can hit your R value, hit enter, and then you have your answer. There is also a shortcut on the newer calculators. that is, I think alpha y equals. Alpha y equals has a lot of stuff on there. I love those buttons. So alpha y equals might also have it. Yeah, your calculator is amazing. So if I go to alpha y equals, I have my fractions, but if I go over, I have different functions, and it has this one on here. So it also has the factorial, absolute value, summation, derivatives, integrals, log bases, all that kind of stuff. Or you can just hit the math button, go over to probabilities, and it's the third one. I forgot to hit my n value. On the newer ones, you can actually do it after. So our first example was 7, 3. So we get 35. So there are 35 different ways to take these 3 kids to the park. So we can take the calculator and do either 7. So it might look like this, where it's 7, and then you go find the NCR, and then you hit 3, and then you hit enter, or it might just have, it might pull up like boxes like this, and then you type in the 7 and then the 3. In either case, our answer is 35. And that's not because 7 times 3. Well, 7 times 3 isn't 35. I don't know where my brain went with that. I need a nap. So going through this, we get 4, 0 is 1, 4, 1 is 4, 4, 2 is going to end up being 6, and then 4, 3 is 4, 4, 4 is 1. So just like, so let's look at this 4, 1 and the 4, 3 real fast. If I am, oh, I don't have this up there. There we go. If I am looking at, well, if I've got 4 kids to take to the park and I'm only taking one of them, there's 4 different ways because I could take one of the 4. That's the exact same idea as 4, 3, where I'm taking 3 to the park, because you could also think about it as I'm leaving one home. So whichever one didn't clean their room gets to stay home. So there's going to be symmetry here, but I also want you, before we add these together, that's the 4th row in Pascal's triangle. So I don't actually care that we're going to add them together. It's 10, 15, 16. But so when we're doing when we're expanding a binomial, you can use this idea of these combinations to find the coefficients. Now, it's not the coefficient for the whole term. It's the coefficient. It's the coefficient for the term if you don't have coefficients in the binomial, if that makes sense. I'll show you kind of on the next slide how to set up the binomial theorem. Okay, so when we are expanding a binomial, we're going to set up our pieces as our first piece is A, our second piece is B. So if there is a coefficient with A, or a number, like B has, our first example, B is -2, that's going to change the coefficient of the overall term. But the coefficient before we use those is just going to be that combination. So what we do when we're expanding this is saying to take the sum from 0 to n, where n is our exponent. So we're going to take from where n is the exponent. That kind of covered that up. Let me use a lighter color. How do I make this? I forget how to make it. This one? Nope. I don't know how to make it opaque. Whoa, I don't know what I just did there. Okay, we're just gonna underline it. That works. Yes and no. Like, if you have variables, your calculator can't necessarily do variables. I'm sure there are calculators out there that can do this, but not anything that's allowed on the ACT. So whatever that n is, that's what we're putting here, and then that's also what we need for the exponent. So that's going to play a big part in all this. So we're going to go from 0 to whatever our expansion is, and then we're going to have that combination, and then we're going to have our first piece and our second piece set up. So it's actually, it'll make more sense once we do an example. It's exactly what we just did the last example with expanding using Pascal's triangle. It's just now we have combinations to find the values in Pascal's triangle. Okay, so let me write it out. So for this one, we have x minus 2 to the 5th. So my a term is x. My b term is -2. And my n is 5. So what I'm going to do is I'm going to write out 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, and 5, 5. This exists because, do you want to expand out x minus 2 times x minus 2 times x minus 2?
I will gladly do that because I don't understand where the 5 is coming from. That is on top.
It's the n term.
And then, okay, so it's the n term as well as the number we're counting up to?
Yep.
Okay.
Because our summation is, oh, it didn't connect it. Our summation is saying to go from 0 to that n term.
So this probably makes more sense if I understood this series.
Not really.
Oh. Okay.
So what we're doing is we're taking our n term, so in this case 5, right? And then this is the number that we're going to cycle through. So 0, 1, 2, 3, 4, stopping at 5. So r equals 0. Wait, do you understand the summation notation?
No.
Okay, yeah, that's probably where you're confused.
Okay.
So yes, that part of the assignment, it would be helpful to know. But even if you don't understand the notation, you will be okay. So then we're just gonna have our top number be whatever the expansion is. The bottom number is gonna go from 0 to whatever that expansion is, okay? Those are our coefficients for these pieces. And then we're gonna take our first piece, so the x, and start at 5, 4, 3, 2, 1, 0. Then we're going to take the -2 and say, well, my exponents here need to add up to 5. 5 plus 0 is 5. 4 plus 1 is 5. 3 plus 2 is 5. Then that's going to be a 3, 4, 5. That's the setup each time, and then you simplify it and add the pieces together. So we can use our calculator to do 5, 0, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5. Or you can, I recommend doing it that way. So 5, 0. So how many different ways can I choose 0 things? Well, just the one way. I choose none of them. 5, 1, how many different ways can I choose 5 things? Or how many ways can I choose 1 thing? 5. And then it gets a little bit more complicated that I don't want to think about, so I'm going to pull up my calculator and say 5, 2. Oops. Which is 10. And then 5, 3, which is also 10. So you can see that there's going to be a pattern here. So now I can just copy those numbers over. So then I have x to the 5th, that didn't change, x to the 4th didn't change, x cubed, x squared, x to the 0 is just 1. Then I'm going to look at 2. Negative 2 to the 0 is just 1. Negative 2 to the 1st is negative 2. Negative 2 squared is 4. Negative 8, 16, negative 32. And then I'm going to write out my answer. So I have 1 x to the 5th. You don't have to write the 1. So 5 times negative 2 is negative 10. X to the 4th. 10 times 4 is 40. X cubed. Then we have negative 80. X squared. 5 times 16 is the same thing as 5 times 4 times 4. So I have 20 times 4, which is 80. Or you can just use a calculator. And then my last piece is minus 32. So that is the expansion for that. So we have n is 4. And then my a term is 2x. It doesn't necessarily matter that they're like a and b. It's just the first and second piece. So what this means is I'm going to use that 4 and go 4, 0, 4, 1, 4, 2, 4, 3, 4, 4. If it had been like a 3, I would do 3, 0, 3, 1, 3, 2, 3, 3. So then the next piece is to take the 2x. So 4, 3, 2, 1, 0. Now, technically, because of the symmetry, if you wanted to start at 0 and then go to 4, that would work as well. And then we're going to take that b value, negative 3y, 0, negative 3y to the first, negative 3y squared, negative 3y cubed, negative 3y to the 4th. Now those come from the fact that my exponents, this 4 and 0, have to add to 4. 3 and 1 have to add to 4. 2 and 2 have to add to 4. But they also match these numbers right here. So 0 exponent, 1 exponent, 2 exponent, 3 exponent, 4 exponent. So then using the calculator, we can figure out 4, 0. And that is going to be 1. 4, 1 is 4. 4, 2 is 6. 4, 3 is 4. 4, 4 is 1. And you can just type that into the calculator if you need to. So 4, 0 is 1. We already did that part. So if I wanted 4, 2, that's 6. So you can do that. So either look at Pascal's triangle or you can just type these in. Okay, the next thing is now I have 2x to the 4th. Well, when I take 2x to the 4th, I'm raising the 2 to the 4th and the x to the 4th. So I'm going to write that out. 2 to the 4th, x to the 4th. 2 cubed, x cubed. 2 squared, x squared. 2 to the 1st, x to the 1st. anything to the 0 power is 1. And then we do the y pieces. So anything to the 0 power is 1. Then I have negative 3 y to the first. Negative 3 squared y squared. Negative 3 cubed y cubed. Negative 3 to the fourth y to the fourth. So you need to understand properties of exponents and how those work. Then we can basically type everything into the calculator that's a number. So I can do 1 times 2 to the fourth times 1. So that's going to be 16. Then I can type 4, 2 cubed, negative 3. So that's going to be negative 96. So if I did that on the calculator, I could do 4 times 2 cubed times negative 3 to the first. No, I didn't need to put it to the first, but I'm going to show you what happens. Then I can do this again, but change those exponents and the 4. So the 4 turns into a 6 for my next piece. And then I'm doing 2 squared and negative 3 squared. So then I can make the calculator do as much or as little as I need it to. Okay. So then that's next coefficient. So 6, 2 squared, negative 3 squared. Oh, no, I forgot what the number was. 216. 4 times 2 times negative 3 cubed is negative 216. 1 times negative 3 to the fourth is a positive 81. And then we still had x to the fourth, x cubed, x squared, x, y squared, y cubed, y to the fourth. And I'm okay if you leave your answer written that way. Or you can turn it back to kind of more a traditional sense and rewrite it this way. I don't care how you write it. Oops. So for something like this, here we go. I know that my n is 9, and so whatever I have is going to be 9 some number, right? I just don't necessarily know which part it is. And I could go through and write out 90, 91, 92, 93, 9, all the way to 9. No one wants to do that. Don't do that. If that's the only way that your brain is going to allow you to do it, then that's fine. But I don't want to do it. So then we're going to have 2a raised to some power and negative 3b raised to some power. Now we're looking for a cubed. The only way to get a cubed is if there's a 3 here. That's going to give me my a cubed term. This is going to allow me to find the other pieces because what do the exponents need to add to? 9. So 3 plus what is 9? 6. And that number is going to match this number, except because of the symmetry, you could actually put a 3 there instead of the 6 and it would be the same thing. Because if I have 9 kids, I really like this park. If I have 9 kids and I'm taking 6 to the park, how many am I leaving at home? 3. So that's the same thing as saying I have 9 kids and I'm leaving 3 home. How many ways are there to do that versus 9 kids taking 6 to the park? So this will also be the same thing as 9, 3. So again, because of the symmetry, no, you do 9, 6. I'm just saying like either one will work. You get the same answer. So I don't care how you do it. So on your calculator, we're going to do 9/6 or 9/3. So 9 math over 2 probabilities, NCR, and then 6 is 84, or 3 will also give me 84. So then that piece is 84. And then I have this 2a cubed. So 2 cubed, a cubed, negative 3 to the 6th, b to the 6th, and then I just kind of clean it up. So we're going to do 84 times 2 cubed times negative 3 to the 6th in the calculator because I don't want to think about that. So 84 times 2 cubed times negative 3 to the 6th. Well, I know if I'm raising it to a positive power that I'm not going to need the negative there. So that's a big number. So then that number, let me write that down. 4 and 8, 4, 8, 9, 8, 8, 8. Okay, and then it's going to be a cubed b to the 6th. So that would be the term with a cubed. So to do something like this, we're going to have 12, so I'm going to kind of write things out here. 12 to 12 something in our combination. And then we're going to have 2b squared with some exponent. And I'm going to use, let's use x and y. So I'm going to use x. And then we're also going to have negative 1 over b to some exponent, right? That's gonna be our setup. So the way that I view these is I ignore the numbers because I need to find b to the 6th. So there's actually a few different ways that you can do this. I'm going to rewrite this as 12 something 2b squared to the x. To move something to the numerator, you can put a negative exponent with it. So this is the same thing as negative b to the negative 1. And then, again, you can guess and just see which ones work, or you can kind of set up a system where we have that just looking at the b's, I'm going to have b squared times, or b squared raised to the x. So you multiply those. And then I'm also going to have b to the negative 1 to the y. And I know that I'm looking for my b to the 6th term. And so you can use your properties of exponents to turn this into 2x plus negative y. So minus y is equal to b to the 6th. And then you can use the 1-to-1 property. So 2x minus y needs to equal 6. But then we also know that x plus y has to be 12 because those exponents have to add up to 12. And then you can do a system of equations. So I'm going to rearrange this. So this is the same thing as 2x minus 6 equals y. And then substitute that in. So x plus y, but y is 2x minus 6, equals 12. So 3x equals 18, x equals 6. So now I can plug 6 in here. Now, another way of doing this is just kind of seeing what works. So if I have b squared to something times b to the negative 1 to the something, and I need this to be b to the 6th, I can try different things. So I could do like a 5 here and then 7 here because those have to add up to 12. And then I can say, well, this is b to the 10th, b to the negative 7. That gives me b to the 3rd. That didn't work. And then you can keep trying something. So you can always just guess and check, or you can use like a system of equations, but you have to know your properties of exponents. If you don't know the properties of exponents, this is not going to have a good time. Once I have that my value is 6, so if we were just guessing, that would give me b to the 12th times b to the negative 6. Hey, that's b to the 6th. Then I know that I can kind of put those values back in. So I have 12 to the 6th, and then it's 2b squared to the 6th, and negative b to the negative 1 to the 6th. And then I solve that by using a calculator. This gives me 924 times 2 to the 6th, b to the 12th, times a negative 1 to the 6th, which you don't have to put because that's going to be a positive 1, times b to the negative 6. So then we get 59136 when you type that into the calculator. So if we were to do 12.6 in the calculator, so we'll go ahead and do it. So 12.6. Oops. And then we can take that number and do 2 raised to the 6th power times negative 1 raised to the 6th power is just going to be 1. So that's how we get that number as well. And then it's b to the 12th times b to the negative 6. So we can combine those to be b to the 6th. So then the coefficient, because it was just asking for the coefficient, is that number.